Like you have to learn the basics, right? Obviously. think- So this class is mainly on the basics of friction, like to understand what is meant by friction and little bit quantitatively how to define it. So that's it. Like, shall we start?
या यू कैन स्टार्ट। सो भैया ने कहा कि ये फ्रिक्शन के बारे में आपको बताने वाले हैं, और आपको इसके बारे में आपको पता है ना बेटा, ये टॉपिक सब लोग। विच चैप्टर इज दिस फ्रॉम द बुक? कैन यू शेयर द कैन यू हैव
Still,
एक्सेस टू, या विच चैप्टर इज दैट इन द
with loss of
फिजिक्स?
motion.
लॉज ऑफ मोशन। ओके, लॉज ऑफ मोशन
Yes.
में फ्रिक्शन आप टॉपिक पे भैया एक्सपेरिमेंट आपको बताने वाले हैं। ओके, सो ऑल द स्टूडेंट्स प्लीज आपका आपके फिजिक्स चैप्टर से, लॉ ऑफ मोशन से, फ्रिक्शन चैप्टर से ये वर्चुअल एक्सपेरिमेंट भैया बताने वाले हैं। ओवर टू यू, वी में स्टार्ट।
Hmm. Once. Uh, Once. Let me share my screen.
या आई मेड यू को होस्ट।
Yeah, yeah.
So what you do is you just click the three dots in the uh, just the arrow which you can see on your laptop. Click there and then present now. Jaswant, are you there? I think Bhaiya has left the class.
इनका मैम कुछ नेटवर्क एरर हुआ है, हाँ वो उन्होंने एग्जिट किया है अभी।
हाँ कोई बात, he is back. So Jaswant, I made you co-host. What you need to do is just see the arrow. In that arrow, when you click, then there
Hmm.
is a present now icon. You just click that and then you further share.
No doubt.
Yeah.
One second. Hmm. Think it's visible, right?
Absolutely.
Yes.
You have to tell them in from scratch.
Okay.
जितने भी बच्चे हैं, आप लोग को मैं बताती हूँ एक चीज, ये एक वर्चुअल लैब का सेशन है। आपके जो एक्सपेरिमेंट्स जूनियर कॉलेज में होते हैं, कॉलेज में अगर आपके पास लैब असिस्टेंट है या साइंस टीचर है, उसी लैब एक्सपेरिमेंट को भैया वर्चुअल प्लेटफॉर्म पे, ऑनलाइन प्लेटफॉर्म पे कॉन्सेप्ट अंडरस्टैंड करने के पर्सपेक्टिव से आपको बता रहे हैं। ये थोड़ा मुश्किल लगेगा, लेकिन इतना भी मुश्किल नहीं है। आप प्लीज इस इंफॉर्मेशन को अच्छी तरह से समझिए। अगर कोई सवाल है तो पूछिएगा, आपको अनमोल मैम बता देंगी भैया को इंग्लिश में। भैया को हिंदी समझ में आती है, ठीक है, लेकिन भैया आपके साथ सारी बातें इंग्लिश में करेंगे। ओवर टू यू जसवंत।
Okay. So to start, like everyone knows what is a force first. Does everyone know that?
इंटरेक्ट करना पड़ेगा। फोर्स सबको पता है, जिसको पता है आप थम्स अप करेंगे या फिर यस नो बोलेंगे, या व्हाट इज फोर्स आपको उसका जवाब देंगे। अदरवाइज इट विल बी वेरी डिफिकल्ट फॉर हिम टू टीच। So okay, very
Okay.
well.
At least one person knows.
No, many
Okay.
of them they knows. They are smart guys. मुझे पता है
Okay.
सभी बच्चे जो जुड़े हैं बहुत स्मार्ट है भैया की तरह. वेरी
Oh,
गुड.
okay. So if you know, like, you know what is a force, then the friction is nothing but it's just a kind of force which comes into play in some situations. And like there are many types of frictions. Like, so friction is like some opposing between relative motion between two surfaces. If you there's something there are two surfaces, and if assume like there are two hands of me. Can everyone see me first? Am I visible to everyone?
Yeah, just you are visible.
So is if you look at the two of my palms, if I try to slide each of them, so try to press and try to slide, so you can feel some resistance. Like you generate heat, right? Using this. So it's similar to that. So there is some resistance while you are trying to generate heat using your palms. So like that's caused by friction. So the main thing why friction acts is some because every surface is may it may look even, but it's not even. It's uneven, and it has so many up up and downs and zigzag things. So if you try to, if there are two surfaces in contact, so there is some kind of locking in between the up and downs. So if you try to slide, they will resist, like, and they will not allow the other surface to pass. So that's like intuitively what is friction. So we'll try to make it a little bit quantitative here. So, so you can say intuitively if you like press the both hands to like more, it's harder to move. Like if you try to press each other closer, it's very hard to move, right? Because so you know what is normal reaction meant by. Mm. So like, does everyone know what is in meant by normal reaction? Hello, am I audible?
Ashwin, बच्चों आप लोग साथ में यस नो बोलो भैया कुछ पूछ रहे हैं
Yeah,
ना
like
आप लोग को समझ में आ रहा है
you may not talk, but you can just show the symbols.
Yes,
Yes.
sir.
या यू कैन थम्स
Yeah.
अप या आप लोग थम्स अप या कुछ भी इमोजीज वहां पे ना रिएक्ट कर सकते हो थम्स अप बता के कि आपको समझ
Yes.
आ रहा है
Yeah. You know what is normal reaction, right? So you can intuitively say that like when normal reaction is more, there is more friction. That you can understand it. So the reaction the relation is like the friction grows linearly with the normal reaction, but not continuously. So it stops at that point. So you can see this graph, right, in this picture. So mm, okay. So there is a picture here in the graph. You can see that. So I think this applied force is just like a normal reaction thing. And no, this is different. One second. In that graph is there is no that graph present, but let me say normally. So if the there is something called static friction. Static friction is like acts when there is no relative motion between the two surfaces. So there is no motion, but it resists the motion that is meant to be initiated. So like this, if I'm trying to slide one of my hand on this, so I'm not moving the hand. One hand is is in rest with respect to other, but it's trying to slide. I'm applying force, but it's not moving, and it's not moving because there is something called static friction. Like it opposes the motion. So static friction is something which acts when the both surfaces are rest with respect to each other, and kinetic friction acts when one is in motion with respect to each other, like this. So for the mm, Now the static friction is not always the same. Like there is some a range. The range is like from starting from zero, right? Like this, there is no friction actually. And like when I try to increase the force applied, the friction also increasing. So at a point, the against the friction against to me is not sufficient enough to stop my force. So the hand starts to move. So this upper bound of the static friction is linearly proportional to the normal reaction. This everyone understood it. Does everyone understood this? Like what I
आप
mean
लोग को
by
समझ
upper
आया?
bound?
समझ आया जो
Yes.
भी भैया ने समझाया? आप लोग थम्स अप करो.
Yeah. So there is some like static friction is not always same. It has a range from zero to some upper bound. This thing everyone understand it. So after this, the upper bound of static friction is something a proportional to the normal reaction, and it's given by this. You can see that like the Fs is mu s times r. So there is something called coefficient of friction, which relates the friction and normal force. So the Fs equal mu s into r is not exactly true always. Here Fs is just upper bound of the static friction. It's not exactly what is static friction. This everyone understood. Please, like this, you could not confuse in this. Everyone understood this. Please respond. Ah,
बच्चे some students are
some
raising their hands. Yeah.
yes, yes.
जयेश, श्रवणी, आप लोग के कुछ क्वेश्चंस है तो आप लोग मैसेज बॉक्स में डालो या यहाँ पे आप लोग बताओ.
Um,
मेरा क्वेश्चन है मैम.
yes, you tell me.
Why friction use?
Mhm. You can say in Hindi maybe.
Why friction is applied?
Friction is applied. Like friction is not applied. Like it's like a property of an object. So like the surface is not even. It's like an up and down thing. So if I try to give an example, let me try. So it's like two interlocking things. Two surfaces are not perfectly smooth. There are some rough. So if you try to slide between two surfaces, there are some interlockings happening. Look, I think, can I draw this here somewhere? Yeah, like, so the surfaces are not even. This is one surface and oh shit. So like this is one surface and another surface is like this, maybe. So there are some interlockings happening. So that's what causes friction. Is it clear?
Yes.
Yeah.
One more question.
Yeah, yeah. Yes, yes.
Can friction have direction?
Yes, obvious. I want it to have direction. It is a force, right? Then it will have direction. So it's against to the relative motion. So it's like two of my hands. This is trying to move upward and this is trying to move downward, let's say. So the relative motion, so like with respect to this hand, this moves upwards. So friction acts downwards. And with respect to this hand moves downwards. So friction acts upward on this. So it's always opposing the relative motion. That's it.
Okay.
Some other person has a doubt. Like someone else was raising hand. Mhm. Shravani Bhosle. Something.
श्रवणी, आपके कुछ क्वेश्चंस है तो आप पूछ सकते हो.
No, ma'am.
No. Okay. Fine. Okay. Okay. I think it's by mistake. Some.
जयेश इज ऑल्सो देयर। जयेश, आपको कुछ पूछना है, आप पूछ सकते हो खुद को अनम्यूट करके।
नहीं मैम।
Like, you are done, right? You are done with your doubt. So now next kinetic friction. Kinetic friction is some which acts like if there is some relative motion, then kinetic friction acts. So it's like one of my hand is sliding on other hand. So there is some relative motion between the two hands. Then the friction acting is not static friction. It's like a different kind of friction. It's called kinetic friction. So and the kinetic friction is always constant. It's not like it doesn't have any range. It's always constant. For a given normal reaction, the kinetic friction is just mu k times r. So this is called some coefficient of kinetic friction. And in this graph, like there is an object. So like, this is the situation. Right? There is an object and there is some mass hanging to in the thread. So if you increase the weight hanging there, so the thread applies more force on the block. So this is like the applied force is just like some kind of increasing the weight of the hanging portion. So initially the block is at rest with respect to the table. If you try to apply more force, the block initially doesn't move. So initially the force is zero almost. As the force is slightly slowly increased, the friction is also increased. Initially it's static friction because initially it is in rest with respect to the table. Now if you try to apply more force, the block is having more friction acting on it. So at a stage, you can see this peak, right? Saying Fs is mu s times r. There is one peak. So the static friction has reached its maximum level at that point. So after that, it cannot like it cannot oppose more than that. The static friction has reached its maximum value. So the body starts moving because the applied force is larger and the opposing force is less compared to it. So body starts moving. At the instant it starts moving, so the static friction is not acting now. They just converted into kinetic friction, which is lesser than the static friction in general. So you can see that graph suddenly the friction force decreases and becomes constant. And it doesn't matter how much force, more force you apply. It's just like if you increase the force, the body is moving implies there is kinetic friction. That's it. And it doesn't depend on how much force is applied, nothing else. If it's moving, the friction is kinetic. That's maybe we'll try the simulator once. Think you can you understand this graph, right? What is kinetic, what is static friction? That someone had it out. No? No. So everyone understood this. What is kinetic friction? What is static friction? Maybe we'll try the simulator. Everyone can see this, right? Just give a thumbs up. That's it. You don't need to speak or something. I think you can unmute yourself and Harshil, you're raising hand.
Uh, I had a question.
Yes, yes.
what is the difference between kinetic friction and static friction? Like, what are the differences?
So what do you understand by the word static and kinetic? Can you tell? What what do you understand by
Static means something that is stable or isn't moving, right?
yes. So kinetic is opposite to that.
Kind. Yes, yes,
So, friction is not like one property of one object. Like it's like a property of two surfaces, right? That you
yes,
understand that. So it's
yes.
like with respect to one surface, if the other surface is not moving, and you are trying to move, create a relative motion between the two surfaces, then the friction is acting is static friction. If there is a relative motion initially, then the friction acting was kinetic friction.
Oh, okay. That clears my doubt. Thank you.
So, so let's try this simulator. So, so the block weight is this. You can see this block on the table, and if I try to increase the hanging weight, so in this weight 300 grams doesn't move the block because the tension in the rope is not sufficient to overcome the static friction of the block. So the block is not moving now. If I try to increase the weight, it's like 400 grams, uh, still it's not moving because still the static friction is dominating the and tension in the rope. So it's not moving. I think you can neglect this stuff. It's something not related to this. So I think after 400, the 500, when the weight is 500 grams, the block just moves because the friction, the upper bound of static friction is less than the tension of the rope when the weight of the block is 500 grams. So the block starts moving, and the instant block starts moving, the kinetic friction starts acting. Now, one more point is like here you can see something called material. So why is that? Because so the thing called the you can see this right coefficient of friction. It doesn't depend on some object. It generally depends on the surface, like the material of the two surfaces. It's not. It will not change by the object. Is that depends on the surfaces, like which material are the surfaces are made up of. So and there is some and the friction depends only on these two, like the coefficient of friction and this the normal reaction. It doesn't depend how much area is in contact. Nothing else. So you can understand this, right? So I think so. If I try wood in steel instead of wood, so so the friction between the steel and steel is more than the wood and wood. So even though the here the hanging weight is more than 500, it's around 700 grams, but still it's not moving because there is more static friction in case of steel and steel here. In- yeah. So it takes around 800 grams of hanging weight to initiate this motion. So you can see that, right? And it's not depending on the material, it changes. Think I guess this should be even more. Yeah. So it's like between glass and glass, the friction is even more. Like it is little bit counterintuitive. Like you assume that glass and glass is a smooth thing, but there is some another cause for friction instead. It's not just interlocking between the two. There is another cause also when the surfaces are smooth. in thing which is not required for you. But so the interlocking is not the only cause of friction. There is something called cold welding, which I also don't know in deep because it's not that much covered in the 11th and 12th syllabus. This was taught by my teacher. That's it. So there is another thing called cold welding. I don't know that much deeply about that. So because of that factor, even though glass is a smooth thing, so glass and glass have more friction because of that. Like glass on another surface, it may not have that much friction, but glass and glass have very high friction because of that. Oh, shit. Think it's done, right? Think I'm done with the experiment. You can ask whatever you want, doubts or something.
भैया कह रहे हैं कि उनका एक्सपेरिमेंट्स कंप्लीट हो गया है. अगर आपके एंड से कोई क्वेश्चन है तो आप क्वेश्चन पूछ सकते हैं. जयेश, प्रशांत, हर्षिल, श्रव. Prathamesh, any question?
No, ma'am.
I actually, you can continue, Prathamesh.
Harshil, you can continue. Prathamesh.
I had a question where in which part of our day-to-day life, sorry, is friction actually useful or is it playing a part in there?
So मतलब positively or negatively? Like you want friction or you don't want friction in it?
Maybe both, but when does it help us positively?
Like while riding a cycle, you want friction. While walking, can you walk without friction? You'll just slip, right? So you cannot walk on a wet floor because there is no friction, you will get slipped. You need friction to maintain the posture and balance. So like while walking, the thing which causes you the motion was friction because there is no another external force other than friction. So that's it. Right? So you cannot move by yourself. You are applying, so you're trying to make a relative motion between the foot and ground. So you're trying to apply the force on the ground backwards. Like you're trying to push the ground backwards. That's what's causing a force on your foot out in front direction. So you will move using that foot friction. So negatively also like you can understand in some machinery work. So if there is something like piston or something during, so if you in industrial thing you can like friction causes some heat losses. So like efficiency of machines can decrease because of it. So both are obvious, right? Both positive and negative effects are there for friction.
Okay.
Ma'am, do they have the access to this website? Ma'am?
Jashwant?
So like, can they have access to this website? This the
Which
OLabs
one?
thing. So the website I'm using like OLabs, the simulator website. Do they have the access to this website?
Just a minute. प्रथमेश, जो लास्ट टाइम आप लोग की लैब हुई थी तो भैया ने लास्ट टाइम भी आप लोग को वो एक्सपेरिमेंट शेयर किया था ना, तो आप लोग की ओपन हुई थी आप लोग के एंड से?
यस मैम, सुरक्षा मैम ने भी हमें शेयर की थी वो लिंक.
हाँ, just
Okay.
when they have the access.
So there are some questions here. So will you try on your own or should I discuss those questions? Can someone say this? Will you try these questions or should I discuss?
भैया पूछ रहे हैं कि आप लोग एक्सपेरिमेंट्स में जो भी क्वेश्चंस है वो खुद से ट्राई करेंगे या फिर डिस्कस करना है?
Because we have enough time, I think.
Yeah, Jashwant, you can continue. You can discuss.
Me. I think there is some other person having some doubt before.
आप लोग किसी को कुछ भी डाउट्स है अभी तक जो भी भैया ने समझाया है तो आप क्वेश्चंस पूछ सकते हो, नहीं तो भैया आगे फिर प्रोसीड करेंगे, आगे नेक्स्ट पढ़ाएंगे भैया। हर्षिल, जयेश, प्रशांत, संतोष, एनीवन, श्रवनी?
Okay. So does anyone want to try the first question? Nobody wants to answer the questions. Hello.
आप लोग इसमें से कोई ट्राई करना चाहते हो क्वेश्चन नंबर 1 का आंसर? आप इनबॉक्स में भी आंसर कर सकते हो या फिर माइक ऑन करके
Yeah.
बता सकते हो नंबर 1 का कौन सा ऑप्शन राइट है। No one is answering. प्रथमेश, जयेश, एनीवन? इसको आंसर पता है, नहीं भी आता है तो आप बोल सकते हो।
Both 1 and 2.
So can you explain it? Can you explain why electromagnetic force is a correct thing? Why do you think electromagnetic force is a reason for friction? Hello. The person who answered this question, can you respond? Okay. So electromagnetic is like, I just want to tell one statement. So in daily life, any other force you experience other than your weight, everything is just electromagnetic force that you can believe. So does everyone know what are like types of forces? Do you heard what are types of forces? Hello. Someone respond. Like you should respond for this. Hello.
आप लोग कुछ भी आंसर करो अपने एंड से, यस नो, नहीं आता है तो फिर भैया बताएंगे आगे, बट आपको बोलना पड़ेगा अपने।
Yes. You have to interact to learn, not just sit.
आप लोग अपने इनसे नहीं पूछोगे, नहीं बोलोगे तो फिर भैया को पता कैसे चलेगा, है ना? आप लोग डायरेक्टली इंटरेक्ट करो अपने एंड से। नहीं भी आता है तो आप क्वेश्चंस करो, आगे भैया एक्सप्लेन करेंगे, बट बोलना होगा ना, हाँ भैया मुझे नहीं समझ आया, आप प्लीज रिपीट कीजिए।
You should also think about the question, right?
Yeah, okay.
So like everyone knows what is friction before this class, or you hearing first time? What is, there is something called friction. Is this your first time you know what is friction?
भैया पूछ रहे हैं कि आप लोग पहली बार फ्रिक्शन के बारे में आज सुन रहे हो, क्या इससे पहले आपको पता था दैट व्हाट इज फ्रिक्शन? एनीवन? प्रथमेश, यू? आप लोग को पहले से पता था? ओके, भावेश आप बोलना चाहते हैं, बोलिए।
opposite forces between two surfaces.
हाँ मतलब आई एम नॉट आस्क, मैंने फ्रिक्शन के मीनिंग नहीं पूछ रहा हूँ, बस आई एम जस्ट सेइंग कि you know friction before this class or you are hearing this for first time, that's it.
Yes, yes, पता
You
है.
know what is friction, right? Before this class.
Yes,
So
yes.
if you know, please interact, right? Please try to interact. So anyone just tell me what is this first question. Try to explain me the answer, not just an option.
Question first या second?
Like, give me some small explanation why it's that's the option. Okay. So I think I will just tell all the questions, I think. So the first question, what which of the following is a reason of friction? So the in daily life, a reason for every force other than your weight is just electromagnetic force. This you can remember, maybe. You will slowly understand what the explanation maybe in 11th and 12th. I am not sure whether it's present in your syllabus, the chapter forces, what are forces, types of forces. But if you, after some time, you will know in detail what are types of force or something, then you will understand that other than your own weight, everything is else is electromagnetic force in what you feel. Like there are some other kind of forces, but they are not something you observe in your daily life. They're like nuclear forces. They act on very atomic scale. So that's not the reason. So, and the third one is just what I was saying from start of the class, interlocking of projections and compressions of surface. So next, the second question is saying, is it a what type of force, contact or not contact? So what do you mean by contact force? Is like which acts when the two objects are in contact. This is not talking in a microscopic level, not in atomic scale, but it's talking in some macroscopic kind of. So if you take two magnets, they have force in between even though they are not in a contact. So the force acting there is non-contact, but friction is not something which acts when two layers are not in contact. It acts when the two surfaces are in contact, right? So it is a contact force. So the third question is like, what is reason for slipping while walking on ice? Since someone was asking how where you observe friction in daily life, so that's the question. Why you slip on during walking? Because it's not because, so the first option is obviously false. normal reaction is same. It's independent of what's beneath your leg. So it doesn't matter what's under your leg, it's ice or anything. The normal reaction is always just your weight. So it's not true. The if you have a lot of friction, you will not slip. So answer is like it's you have very little friction. In the fourth question, what is direction of friction, frictional force? This thing I already said, it's just opposite to the direction of movement of the object. Yes. So I was just saying it's opposite to relative motion between the two surfaces. So what best describes friction? So friction is just a force and forces are vector quantities. What is type of friction when a body rolls over another body? So there is, so this is rolling friction. There is so rolling friction is not a particular new type of friction. It's just static friction, but so it's a special case of static friction, and it is given a name because you use this rolling thing everywhere, right? So like on your bikes, something on bicycle, everything uses this rolling friction. So I think because of it has so many applications, it's given the name rolling friction. If you prepare in JE also in 11th and 12th, so in mechanics you will see the rolling friction thing in most of the questions. So rolling friction is not a new type, it's like a type of static friction. So yeah, which of the following statements is correct? Okay. So in general, ro- so the rolling friction is very less because you can observe it, right? While you are cycling, if you try to roll an object, so if there is cylinder or something like some lawn roller thing, you generally will not try to slide it on the ground. You just try to roll the things on the ground, right? You can observe this. The rolling friction, the friction while acting, so the friction that acts while rolling on an object is very less. So the reason is like you will understand after if you so in 11th and 12th, if you do the rotation mechanics, you will understand the reason. So without that, it's a little bit hard to explain why it is very less. Maybe you will understand it in your 11th and 12th grade. I don't know which class you are. Okay.
All are in class 11th, Jashwant.
Oh, then I think they should know they should know what is they should be done with rotation mechanics, right? Most probably. No.
Yeah.
So everyone has like know what is rotation mechanics is started or it's about to start for everyone in school.
आप लोग से पूछ रहे भैया कि रोटेशनल मैग्नेट आप लोग पढ़ चुके हो या फिर आगे पढ़ने वाले हो? प्लीज आंसर. आप लोग आंसर नहीं करोगे तो फिर कैसे समझ में आएगा? एनीवन, आप लोग रोटेशनल पढ़ चुके हो या फिर आगे पढ़ना है आगे के चैप्टर्स में, या ये टॉपिक आप लोग पढ़े हो पहले? रोटेशनल फ्रिक्शन आपने
नहीं हुआ ना, कंप्लीट नहीं हुआ, स्टार्ट नहीं हुआ रोटेशन मैकेनिक्स.
स्टार्ट नहीं हुआ
Okay.
अभी?
नहीं.
हाँ तो ठीक है. व्हेन रोटेशन मैकेनिक्स स्टार्ट हुआ तो होगा तब यू विल अंडरस्टैंड व्हाई रोलिंग फ्रिक्शन इज लेस. This I forgot to tell. So the maximum value of static friction is called limiting friction. maybe you can understand that by the word limiting. So limiting is like some bound or something. And 10th question. So can anyone tell me the 10th question? So 10th question is just they are saying a force of 294 Newton is required to start moving an object of 100 kg. So in a horizontal plane. So the body is kept on the horizontal plane. A force of 294 Newton is required to start. So they are saying that at least 294 Newton of force should be applied to start motion. So you can say by this statement that maximum value of the static friction is 294 Newton, because the minimum force required to start motion is just maximum value of static friction. If the applied force is less than that, the motion will not start. So this 294 Newton is just nothing but what is maximum value of static friction. That's what they are meant to say. And know the relation between static friction, maximum value, and normal reaction, right? So the normal reaction here, because the object is on the horizontal plane, the normal reaction is just weight of the object. So I think by that you can know what is normal reaction. And if you divide this 294 divided with the normal reaction of the 4, it gives the coefficient of friction. That's it. I think all the questions are done. Maybe you can try these questions again after this class. I think you can check this after the class again. I'm done with the class, I guess. Any more questions?
Yes, Ashwin. Anyone, any questions?
No, ma'am.
No, ma'am.
No, ma'am.
Like any
everyone, आप लोग की next class है अभी biology. हाँ, मैं जैसे
Mhm.